Hi, it's Miss Miles, and today we're going to talk about formulas in geometry. Here are your learning objectives. That you'll be able to use formulas for perimeter, area, temperature, and the Pythagorean theorem. That you can explain why the distance formula is related to the Pythagorean theorem, and you'll be able to use the distance formula. Here's your activator problem. A regular hexagon has a perimeter of 49.5 centimeters. What's the length of one side? Now you want to think about a hexagon, and especially a regular hexagon has all congruent sides. There are 6 of them. So we'll take the perimeter, we'll divide by 6, and here's the length of one side. Definitions for today. A formula is a mathematical relationship expressed with symbols. Perimeter, the sum of the sides of a closed figure. It's the distance around the figure. And the perimeter of a rectangle, just as a reminder, is 2 times the length plus 2 times the width. Finding the perimeter of these figures, it's just a matter of adding those 3 eighths together, or 8 times 3, that's 24 inches. And the perimeter of the rectangle is going to be 2 times 12 plus 2 times 8. Follow order of operations and you get 40 inches. Alright, take a moment and quickly find the perimeter of these figures. So far so good? Let's move on to area. Rectangle, area formula is base times height. Same thing for parallelogram. Triangle is half of the base times the height. And trapezoid is half of the height times the sum of the bases. Remember, the bases are those parallel sides. Let's practice. The figure on the left, use your area formula. Substitute in your base and your height. I always include my units. And now multiply. Not only the numbers together, but the units together. And we get 42 square centimeters. How about that triangle on the right? Substitute in your values. And here you have a choice. Do you want to take half of 3 and multiply that by 8? Do you want to take half of 8 and multiply that by 3? Or half of the product of 3 and 8? I'm going to do half of 8, which is 4. 4 times 3 is 12. 12 square feet. All right. If I asked you to find the height of this figure, this is a little bit more cognitively demanding, because here the variable that we're looking for is the height. So let's substitute in what we know, and let's use algebra to get h all by itself. Let's multiply both sides by 2 to get rid of the fraction from the right. Let's divide both sides by 9, where the 9's cancel out, and we're left with height of 6 meters. In the Pythagorean theorem, you remember, if the leg lengths of the right triangle are a and b and the hypotenuse is c, you'll recall a squared plus b squared equals c squared. Let's apply it. Here we're asked to find the length of the missing side, so you have to determine what is that missing side. Is it a leg length or is it a hypotenuse? It's a hypotenuse because it's opposite the right angle. So we can fill in 9 centimeters for A and 40 centimeters for B. Now let's square each one of those terms. Let's add them together, and let's take the square root of both sides. And I get 41 centimeters as the hypotenuse. So 9, 40, 41 is another Pythagorean triple. To find the area of this triangle, why don't you pause for a second and give it a try yourself? It's a little bit involved. And I'll just project my work and make sure that we match. So if the base is 4 feet, and I got that from applying Pythagorean theorem, half of 4 times 3 is 6 square feet. Right now in temperature, here's the formula that converts Fahrenheit to Celsius. Subtract 32 from the Fahrenheit, multiply that by 5/9. So now let's use this formula to show why 32 degrees Fahrenheit is the same thing as 0 degrees Celsius. Because I'm substituting 32 in place of F. Now do the parentheses, and anything times 0 is 0. Now let's move on to distance formula. To find the distance between these points, what I want to do is turn that slanted line, kind of make it the hypotenuse of a right triangle. Now let's consider the base of this right triangle, okay? And in a squared plus b squared equals c squared, let's call the base A. And you'll notice it's 8 minus 2 units long, right? It's the difference in your x's. Now what about your height? It's the difference in your y's, right? Or 9 minus 1 units long. So in this formula, remember, we're going to substitute our base for A and our height for B. And I'm really looking for the distance between points A and B, right? So I want to find the square root of this. But I look back up at my original points and I think to myself, I can call the first point x sub 1, y sub 1. And I can call the second point x sub 2, y sub 2. And in my last line of work, I can just substitute in the numbers there with the variables, and I can see the distance formula using this concrete example. So when you want to find the distance between points on the coordinate plane, it's the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So that just helps me make sense of the distance formula. Now let's apply it. So that one we've already done. But here's our distance formula, right? It's an important formula to have kind of ready to use. And I can apply the distance formula to solve this problem, or I can even turn this into a right triangle and again use the Pythagorean theorem. But I think I'm going to apply the distance formula just to get practice with that. I feel like it went away too fast. Let me try that again. 5 units. Okay. All right, so let's just be sure that your learning is on track today. How do you feel about these questions? Are you able to use formulas for these different topics in geometry? And are you clear the connection between the distance formula and the Pythagorean theorem? And finally, are you able to use the distance formula on or off a coordinate plane? Can you do that? Okay, thanks for listening today.